thank you so much for that introduction, and thanks for inviting me. It's been a great conference so far. I wanted to talk about this recent paper of mine, which looks at what are called citation gaps, and talks about how they could arise in part due to what I'm calling structural causes. So I realize that's a bit jargony of a title, and I'll explain that terminology in a moment. But first, I wanted to say more generally, the question that I'm focusing on is basically, how do ideas spread throughout academic communities? Or to phrase more in line with the theme I'm addressing, how do individuals' ideas within a community reach the community as a whole so that the collective can make progress, whatever we mean by scientific progress. So one fact that's been significant for philosophers of science, as well as social epistemologists, social scientists, and others, is that the social identity of a researcher can affect their position in the community, as well as the uptake of their idea. So in order to investigate the reasons for this and its potential impact on these communities, it helps to operationalize or be a little bit more specific about what we mean by terms like position in the community and uptake of ideas. So here's how I'll be doing that. So first, to talk about a researcher's place in the community, it's common to use networks, which summarize the various connections among the community's members, along with some measures of connectedness or centrality of researchers. So I'll say more in a bit about how these networks can capture the structure of a community and how social identity can importantly affect this structure. Second, a common way to measure the uptake of an idea by a research community is to look at citations accumulated to published papers, often with some measures of author's impact that are based on citations, like the H index or the I-10 index. Now, there are obviously different ways to operationalize these terms, but relying on these common measures will let us investigate underappreciated causal processes that lead to work by marginalized groups being overlooked. Okay, so with that little bit of a preamble, here's the plan for the talk. I'll start briefly by briefly reviewing some of the empirical literature on citation gaps, which is the observed phenomenon that women and minority group members tend to have their work cited less often in certain fields.
Recording in progress.
So there are a lot of reasons why people throw out for why these citation gaps exist, but generally the empirical work on citation gaps doesn't test the causes of citation gaps, but merely just determines whether or not one exists. So I'll present some mathematical models that I'll argue point to one possible cause of citation gaps in terms of the structure of the community. So I'll explain how people generally capture the structure of academic research communities in mathematical models. I'll then present my own models, which will show how certain structures can be expected to give rise to citation gaps. Okay, so while I think that the investigation of citation gaps is important in and of itself, because it's an important factor in discussions of underrepresentation and things like pipelines, I think what I'll be talking about today also illuminates some general lessons for research in the science of science or meta-science. So a lot of work in the science of science aims to provide a picture of how to achieve well-functioning science or promote scientific progress, but it often doesn't take into account empirical research from other areas of science regarding marginalization and underrepresentation according to social identity. So I'll argue that our picture of how to achieve well-functioning science can change significantly once we take into account how social identity affects a researcher's place in the community and the uptake of their ideas. So in this case, in this talk, I'll talk specifically about alterations to the peer process. Those might play out differently once we take into account social identity. Okay, but first let's start with a quick overview of the empirical evidence on citation gaps. So in many disciplines, gender citation gaps have been found, where male scholars have a higher citation level than female scholars. Field includes fields like economics, ecology, political science, library the information sciences, and so on. Some of these studies also find that women are less likely to be cited in subdisciplines which are more male-dominated. So plausibly, representation matters, as subfields with greater gender balance tend to have smaller citation gaps. While there are far fewer studies regarding citation rates according to race or ethnicity, citation gaps have been found, for instance, in law and social psychology. There are also fields where studies found no gender citation gaps, such as public administration, sociology, international relations, and so on. And there's a couple studies that found that women receive more citations in biochemistry and construction studies. So in addition to all these studies that focus on individual fields and are often focused on particular countries, there have been a couple studies that find that gender citation gaps exist when we look across many different disciplines and across many different countries. Okay, so in addition to these results that look at overall citation rates, one more specific empirical result that will be important for understanding my models of structural causes is what I'm calling citation ratio gaps, for lack of a better name. So in this recent Dion et al. Article, they say that these overall citation counts, quote, miss the sociological aspects of how scholars recognize the work of their. So this is why at least some of these studies on citation gaps also look to see how often men are citing men versus citing women compared to how often women are citing men to how often they're citing women. So basically, they look at a bunch of papers and they see whether the gender of the authors of those papers predicts the ratio of male to female authors in the references, or authors in the references, or something along those lines. So we'll come back to these ratio gaps later. Okay, so we have all this empirical evidence, but what explains the existence of these citation gaps? So some proposed explanations include bias or explicit sexism and bias. And there's some studies showing that bias could be at work, that people's evaluation of a paper can depend on the social identity of the author. And so this may be a potential cause of citation gaps. There's also the productivity gap, where men are found to publish more papers, combined with the fact that they've also been found to self-cite at a higher rate. And there's also the observation that women's research careers tend to be shorter than men's. For whatever reason, there's a dropout gap or pipeline where women leave positions at a greater rate. And all of these are probably relevant factors. But the possible explanation that I'll focus on today is the structure of the community. So as I said, I'll argue that the structure of the community, in terms of who's connected to who and how information spreads throughout the community, might mean that people are less aware of work from underrepresented groups. So this sort of thing has been suggested before, but in kind of a hand-wavy way, by saying maybe women are less well-networked or something like that. So what I'll do is I'll give a little bit more substance to this argument, showing exactly how network structure can affect citation rates in different social identities. So of course, there's many different potential factors interacting. So when we look at these studies on citation gaps, we shouldn't expect the correlation between representation and gaps to be perfect or to find citation gaps in every field. It would be good to know something more about the causes of these gaps. But most of the work I've been talking about is limited to statistical analysis of citation patterns. And it's very difficult in general to test potential causes of something like citation gaps because there's too many factors at play in any given community. So to explore these causal pathways that it's difficult to get access to in the real world, I'll use mathematical models. So these models are nice because they can abstract away from the messy details of interactions in real academic communities and allow us to investigate a particular causal pathway of interest. For instance, the relationship between the structure of the community and the size of citation gaps. Okay, but before I get into that, let me just say one quick thing about how people tend to react to studies showing the existence of citation gaps. So this seems to be a very common reaction that people have when they're told about citation gaps. They respond by saying, I cite whatever paper is best or most relevant, and I don't look at demographics. So on the one hand, this sort of merit defense is likely true of many people who are well-intentioned in their citation practices, and asking people to think about citing members of underrepresented or marginalized groups can seem burdensome or unfair. On the other hand, this sort of response misses the mark a bit. There's this observed phenomenon that happens whether or not any particular individual is biased. And there being this effect is completely consistent with many individuals being unbiased. And if citation gaps are due, at least in part, to structural causes, this sort of response doubly misses the mark. It could be that everyone is using this totally reasonable strategy of citing the best and most relevant papers they're aware of without any bias, and yet this leads to inequities. This is because they're citing the best and most relevant papers of the papers they know about. Yet, due to the way information spreads through their academic community, they just don't know about the relevant papers from a minority. So I'm going to look at the possible ways that the structure of the academic community can affect citation rights from different social events. So first, I'll say a little bit about how academic communities are structured and how we can mathematically capture this structure in a way that lets us say something about how it affects citation patterns. Then I'll use this mathematical representation of academic communities to show how we can get citation gaps in a community of people who don't pay attention to demographics when deciding who to cite. And I'll consider how these structural causes interact with some other potential explanations. So the structure of a community is usually captured by a network, which summarizes who's connected to who. So in the networks we'll be talking about today, we have the nodes, all the little dots, which represent different academics. And then we have edges or links between them, which we can think of as representing something like regular communication channels, like regular collaborations, people who read each other's papers and give comments, something along those lines. Within the network, there are people of different social identity types. And these different social identity types can make up a larger or smaller proportion of the total community. That is, we can meaningfully talk about majorities and minorities within our population. So the communities that I'll talk about today are simplified in that there's only two different social identity types. For instance, men and women, with women being underrepresented and thus a minority in a particular academic. So one very important thing that influences the structure of these communities is what's called homophily, which is the tendency of people to interact within their own social identity group. So there are a ton of different ways to talk about or measure the homophily of the community. But simply put, we can say that there's homophily in a community if a person has a higher probability of forming a link with someone of their own same social identity group than with someone outside their social identity. And the greater the difference between these two linking probabilities, the greater the homophily within the community. So there's a lot of evidence that networks describing both academic collaborations and personal friendships are homophilic. People of the same social identity can cluster within subdisciplines, discipline, and so on. And there's a lot of reasons why people may consciously or subconsciously link more often within their social identity group than with those outside of it. So I took a network image from a paper that I have with Caitlin O'Connor, where we argue that one reason for homophily might be that minority group members break ties with the majority due to an unfair distribution of labor within collaborations. However, networks aren't only homophilic due to people breaking ties. homophily can also result from people seeking out connections with others like them for various reasons, such as receiving support or relevant information about how to navigate the profession as a person like them. In any case, there's good reason to include homophily in the structure of the communities that we're trying to represent. So one way that people capture this homophily is by using what are called multi-type random networks, which I can say more about if anyone's interested, but they capture the fact that people are often more likely to link. So taking all of this about how to represent the structure of academic communities, I'm going to present some models which will help us see how this structure affects citation patterns. I should mention that a lot of what I'm talking about won't be specific to gender, but will apply more broadly to any aspect of social identity that people take to be relevant when forming links within their even though a lot of the empirical work on citation gaps is specifically related to gender. So I'll kind of switch between talking about gender and talking about minority-majority groups, mostly talking about gender whenever I'm relying on specific empirical evidence that's about gender in order to motivate some assumptions. Okay, so I should also mention that these models are in some ways extensions of previous work that I've done with Mike Schneider on how underrepresented groups can be disadvantaged when there's priority disputes over scientific discoveries. So Mike and many people gave suggestions for extending the models in our paper. Okay, so the basic idea behind the model is that we have two very similar papers arguing for or making the same claim. We can say they came out at exactly the same time in similar journals and so on. So basically, all else being equal, does the social identity of the author of one paper make it more likely to be cited than the other paper? And here we aren't considering any biases having any effect. So really the only way that social identity affects citation patterns is by influencing the place that author occupies in the network. So in the model, we start with two people publishing papers on the same specific topic, making a particular claim. And we're interested in the case where these two papers are from people from two different social identity groups, to see, for example, whether a paper by a man will be cited more frequently than a paper by a woman. So each time I ran the model, there'd be one randomly chosen male author and one randomly chosen. Then we have these two papers, which new papers coming out can cite. So the models look at what happens when these new papers come out and counts how often paper one gets cited versus paper two. We draw 200 people at random with replacement from a network to publish a paper. And when they do, there's some chance they're going to cite paper one and some chance they're going to cite paper two, based on how likely it is that they know about the paper. Of course, these new papers coming out also have some chance of being cited, but the model is not going to look at that. We're just tracking how often or how many citations accumulate to these original two papers. For one gets cited more often, or paper two. Okay. So as these new papers come out, how do they decide which of the original two authors to cite? So I made the assumption that if a new paper coming out is by one of the authors of the original two papers, they'll cite themselves. The assumption being that they will know about a paper that they themselves wrote. Hopefully that seems reasonable to everyone. So if the new paper coming out is not by one of the original two authors, then there's some chance that they'll hear about each of these two papers through their network. And this chance is determined by what's called the path length between the author of the new paper and the authors of the original papers. That is, how many links does it take to get from one author to the other? So with probability P, an academic cites their neighbor. With probability P squared, they cite their neighbor's neighbor, and so on, decreasing with the length of the shortest path between those two people. So for the results that I'll show you, I have this probability set at 0.3. So there's a 30% chance you know about a paper from one of your collaborators or friends, a 9% chance to cite a collaborator's collaborator, and so on. But there's nothing special about these probabilities. You can get the same sort of results with different. Okay, so there's some chance a person knows about each of these two papers, and the assumption is if they know about the paper, they'll definitely cite it. And it's also possible that they'll cite both. So here's what happens for different sizes of the Vrije population and different levels of homophily. So we track the citation gap. So how many more citations does the majority group get compared to the minority group? So when there's no homophily, blue line here, both groups are cited equally as often. But as we increase homophily, the relative sizes of the group starts to matter more and more. And in the extreme case, which I can't reach because I'm too short, of the minority group being only 10% of the field and very high homophily, the citation gap is roughly 0.34. So the paper from the majority group member is getting roughly 2/3 of the total citations compared to the minority group getting only 1/3. So this matches with the evidence that women are less likely to be cited in subdisciplines which are more male dominated. That is, fields with greater gender balance tend to have smaller citation gaps. But also remember that it's important to pay attention to the sociological aspects of how scholars recognize the peers. For instance, the finding that men are more likely to cite men, where here men are the majority. Okay, so first let's look at how often men cite men versus how often they cite women in my model. So I call this the ratio in the majority group. So basically, just looking at new papers coming out by men, how many times do these men cite the original paper by a man versus the original paper by a woman? As you can see, this isn't really affected by the size of the majority group so much, but it is affected by homophily. So the more likely it is that men are connected with men, the more likely it is that they'll hear about a paper by a man versus hearing about a paper by a woman. So just to note, even when there's no homophily, this ratio is slightly greater than 1. This is because I counted self-citation as an instance of a man citing man, and self-citation occurs with probability 1. So it kind of pushes it up slightly. Okay, so here's the corresponding graph for the minority group. For instance, how often do women cite men versus how often they cite women? So just like men are more likely to cite men with greater homophily, women are less likely to cite men and more likely to cite women as homophily increases. So their citation ratio of men to women is lower and lower as we increase homophily. In this case, the ratio also decreases as the minority group gets smaller. You can see here. This is just because self-citation has a greater impact on this ratio when the group is very small. So these two ratios together rise to the overall citation gaps. So if men are more often citing men, then as we increase the proportion of men in the population, men will overall be cited more often than women. So one thing that you might think should mitigate this effect, and that a lot of people brought up in response to Mike and I on our paper on priority disputes, is the importance of search engines like Scholar to finding papers to cite. So I'll introduce a second model to incorporate the effect of search engines. So the second model is exactly like the first one, except that when people go looking for papers to cite, they have some chance of finding the paper by looking at their network, asking their friends, and then some chance that they find the paper to cite by doing an internet search. So when you go looking online, there's a couple things to know. First, the chance that you find a paper is influenced by how many citations it already has. In general, a paper with more citations shows up on an earlier page in the search. And second, the earlier a paper appears in the search, the more likely it is that someone will see it and cite it. Okay, so if we include these internet searches, you can see, well, I'll just tell you because you might not remember the exact levels from the first graph, but it does lessen the citation gaps. It doesn't, however, lessen the citation gaps as much as you might expect it to. So one reason for this is that the search algorithm is unintentionally encoding the structural advantage of the majority group. So because the chance you find a paper is influenced by how many citations it already has, and men are receiving more citations because news of their paper spreads throughout the network rate, the chance that you find a paper by a man is greater than the chance that you find a paper by a woman when doing an internet search. So just for some contrast, if everyone's paper was equally likely to be found via an internet search, based on the parameters I used for these results, you'd expect about a 70% reduction in advantage. So the largest citation gap we'd see would be 0.1 versus in the results, it's actually 0.24. So we don't get a reduction from everyone being equally likely to be found during it. Okay, so I've talked about a couple things, but as I mentioned, there are plenty of factors that are relevant to citation gaps, which then can interact with these structural causes. I'm just going to mention two very quickly. So first, we might include bias. What happens if when a majority member comes across a paper by a minority group member, there's some small chance that they don't cite it because for whatever reason, it just strikes them as not worth citing. As you might expect, this increases citation gaps relative to a case with bias. You can also take into account a productivity gap. So forget about bias for now, but incorporate the fact that in some fields, men have been found to publish more often than women. Again, as you might expect, including this increases the citation gap. It does so even when there's no homophily, but the more homophily there is, the greater the effect. And in this case, even when there's equal representation of men and women. Okay. In real academic communities, these effects are not separable as they are in my models, which, as I said, is one of the reasons that I think mathematical models are so useful. But that said, it's important to remember that the factors I've discussed stand in complicated causal relationships with each other and to other factors that aren't included in the model. The one thing that you can't explain just using network structure is that even though citation gaps decrease as there's more women in the subfield, citation gaps still exist in some subfields which are female dominated. And in fact, in many fields, citation gaps have been increasing as representation. So this could be due to bias or a publication gap, things that I've discussed already, or any number of other factors at play, like the fact that as more women enter fields, they aren't necessarily given the sought after research or tenure track positions, but may instead do more of the teaching or lab management labor. Or we might also think that access to good mentorship, which has been found in a lot of cases to be barriers for many social identity groups, is relevant as it could help improve quality of work as well as likelihood of publication and citation. And then of course there's the dropout gap, prestige bias, differences in funding, gatekeeping in particular subject areas, and so on. In any case, I hope this makes it clear that while I do think what I've been calling structural causes are partially responsible for citation gaps, this doesn't mean that other factors aren't relevant. Now, that said, structural causes are important factors to consider, which may be hard to see from data. And additionally, I think that the existence of these structural causes also points to other implications for research. So lastly, I'll talk about these. So in particular, I'll discuss two types of implications. First are implications for how to address citation gaps and attempt to reduce them. And then second are implications for proposals on how to achieve well-functioning science, which, as I mentioned at the start of the talk, don't often take into account issues of social identity. Okay, so I'll just discuss a few proposals to address citation gaps, though of course there are more proposals. So some argue that overcoming citation gaps requires the recruitment of more female scholars and raising awareness about implicit biases that influence citations. Raising awareness of implicit bias could help, but if my argument is right, it won't get rid of citation gaps completely. Improving representation could also help with citation gaps, but as my results indicate, and as studies have found in more gender balanced fields, these citation ratio gaps, where people tend to cite others of their own social identity, would still persist. So whether we should be satisfied with this possible situation of citation ratio gaps persisting as citation gaps disappear, I'm not so sure. And while equal representation is achievable for men and women, it isn't for other social identity categories that might be relevant. So while I think there are good reasons to do both of these things, I'm not sure that they'll be completely satisfactory. And to fight citation gaps due to structural causes, I think that proposals which aim to promote visibility at the community level would work better. Because the problem arises due to researchers not being aware of the best or most relevant papers to cite. Now, of course, there are already some people and organizations who do this sort of thing. Philosopher, you might think of the reading list, or in general, you might think of MC Hammer, who tweets profiles of people from underrepresented groups in STEM. So I guess what I'm doing is in part adding justification and in part calling for more support. And like I said, these structural causes have importance for other things as well. So just in general, in studying the behavior of complex systems, like academic communities, it's important to be aware of potential feedback loops, where initial inequities can feed back into greater and greater asymmetries over time. So the general importance of feedback loops has been noted by many people. Just for one example, Sandy Mitchell. And it's important to keep in mind when using models to study the phenomenon of interest, as you might run into what's called the problem of back reaction. So this is an issue that's particularly important for simple models, which hold fixed certain factors in the background. So for instance, my models hold network structure fixed in the background. But these background factors might themselves change as the result of some proposed intervention, meaning we then have to reanalyze the model in light of this new background. So the damages of failing to account for back reaction have been famously observed in the case of artificial intelligence algorithms approving credit or predicting recidivism, where it's been shown by ignoring racial inequalities, these algorithms create a feedback loop where initial inequities lead to future greater inequities, not only entrenching, but amplifying injustice. So similarly, overlooking marginalization according to social identity may have major consequences when implementing models of how academic communities function or ought to function. So in these cases, paying attention to structural causes takes on increased importance because of the way that they can compound over time. Okay, so what I've just said is a sort of general argument that I think is important in many areas of the science of science, but I'm going to provide a more specific example of how this sort of thing can occur, considering citation gaps and proposals to alter the peer review process. Okay, so there are many well-known problems with peer review, and suggestions for how to rectify these problems are found everywhere. Many advocate abolishing pre-publication peer review, which is the current system, and replacing it with a system where academics publish papers by posting them to an archive where they're then reviewed post-publication. This is argued to be similar to what already happens in parts of mathematics and physics. Okay, so details of these proposals differ, but under this sort of reform, feedback is no longer given by a assigned reviewer, but is performed by the members of the community as they see fit post-publication. I'll argue, in the spirit of the general argument just provided, that these reforms may create feedback loops which not only reinforce citation gaps, but amplify them. And in doing so, I'm going to focus on this argument by Hasten and Bright, which is in a recent paper by a couple of philosophers, because while I've been complaining that people providing these proposals for well-functioning science often ignore issues of marginalization and underrepresentation, these authors actually do engage with these issues in a fairly significant way. So their general argument is that abolishing pre-publication peer review and switching to post-publication peer review is a sort of Pareto improvement or a weakly dominant strategy, not in the sense that game theorists usually use those words, but in the sense that for any standard of evaluating their proposal compared to our current system, abolishing pre-publication peer review is at least as good or better. So this makes for a nice argument because then you don't have to decide how to weigh one factor against another because there's not really that sort of trade-off. So they have a section of ways that they think that abolishing pre-publication peer review would be beneficial for sharing results, more efficient time allocation for scientists, and decrease in gender skew of publications. They also have a section of aspects of science for which the evidence they think is that abolishing pre-publication peer review would make essentially a difference. This includes sorts of epistemic sorting, like saying how high quality an article is, malpractice or fraud detection, herding behavior, the effects of credit incentives. And then finally, they have a section for potential difficulties for their proposal. One they dismiss, saying peer review isn't as much of a guarantee of quality for outsiders as we might think it is. And the other they take somewhat more seriously, but they think is highly speculative. Okay, so I put this all up, but I'm very much not prepared to discuss this point by point or even give an opinion on whether we should abolish pre-publication peer review. What I do want to do is comment on two issues that I think are related to what I've said in this talk. So first, I think this gender productivity gap should be removed from the benefits section, and at best it belongs in the makes no difference section. So here's just a quick argument for this. Many argue that the productivity gap emerges because whether or not there is any bias in peer review, women expect there to be. So women spend more time on each of their papers to ensure its quality is above whatever threshold for publication, meaning they write fewer papers overall. So Hasten and Bright reason that their proposed reform will ease the productivity gap, as women will be primarily concerned to publish when their paper meets their own rather than the community's standards. However, women ought to anticipate biased evaluation of their work separate from the publication process as well. There are various stages post-publication at which gender bias can occur, including the accumulation of citations, as well as in hiring and promotions, the uptake of ideas, and so on. Women, I think, are at least as aware of these things as they are of any potential bias in peer review. And so they'll still be concerned to meet the community's perceived to be biased standards, even if we abolish pre-publication peer review, meaning the productivity gap would still persist. Okay, so the second thing I want to talk about is this runaway Matthew effect, which is a feedback loop whereby, in Hasten and Wright's words, quote, if there's an excess reward for some and an unfair passing over of others at the present stage of inquiry, this will ramify through to future rounds of inquiry, misallocating resources to people whose accomplishments don't fully justify their renown. So initial inequities lead to future greater inequities over time. So Hasten and Wright say a bit about this runaway Matthew effect, but they ultimately conclude that, quote, our present thought is that this is a very speculative objection. There's no empirical evidence to back up the claim that eliminating pre-publication peer review will have dire consequences in this regard. Okay, so I agree with Hasten and Wright on the need for empirical evidence, and that this runaway effect might possibly be counteracted by sufficient additional reforms to protect those most likely to be impacted. But in the short amount of time I have left, I'll try to make a push for this being not so very speculative and an issue that deserves greater attention. And I'll do so by providing another model which demonstrates how a runaway Matthew effect can emerge in the sort of system that Hasten and Wright propose. So I'll talk about this runaway Matthew effect in the context of members of different social identity groups, but I think it's fairly easy to see how a similar argument can apply more generally. And since I don't have that much time left, I'm going to leave out a lot of details of the model, but I will just give you a very basic idea of the mechanics. So scholars go about their research career, both publishing their own papers by posting them to some sort of archive, and engaging with other papers that are posted. Unlike in the current system, in order for a paper to receive post-publication peer review, it must first be seen by others. This can be achieved in a variety of ways: word of mouth, being from those running the archive posts being retweeted, and so on. So the likelihood that someone will read and or share a paper by another researcher depends on many factors. For instance, whether they know that person personally, whether they're familiar with their work, and the reputation of the author. So the likelihood that one researcher shares another work can be represented by what's called a weighted directed edge in a network. So directed edges just point from one researcher to another, while the weight determines the chance that the first researcher will share or engage with the paper. So the first step in creating this model was to create weighted directed networks, where I'll go through quickly. So there are actually way more people in this network, but here's a simplified image. So we start with a homophilic network, like in the previous models, where these links represent something like regular communication channels. We then make it into a directed network so we can consider each direction of the information flow separately. Then, since there's really some chance you'll engage with someone's paper, even if you don't have a personal connection to them, everywhere there was previously no link, I added 2 directed links with a smaller weight just to capture this possibility. So this formalism is well suited to identify the feedback loops I talked about earlier, in particular by tracking how these weights change over time. So in the model, the weights change as papers are shared or engaged with. For instance, as more people become familiar with a person's work as it's shared more often, or someone can gain reputation from publishing a paper with high impact that receives a lot of engagement or citation. So these sorts of factors will increase the weight of edges pointing towards that person, meaning that in the future, others are more likely to share and review the work. The person in the top left gains reputation. That means all of the arrows pointing towards that person are increased by some amount. So by tracking how these weights change over time, we can show how initial asymmetries due to social identity that work from certain social identity group members is more likely to be shared or engaged with can compound into greater and greater asymmetries. So to measure this, I just measured what I'm calling a centrality gap, which is just a measure of how central a person is to a network or how well connected they are, basically. So then the centrality gap measures how much more well connected your average majority group member is compared to your average minority group member. I can talk about the specific centrality measure if anyone's interested. So what I did was I compared the centrality gap at the beginning of this process when I just formed the networks according to that process. I compared that to the centrality gap after 50 rounds of scientists publishing and engaging with each other's papers. There's a scatter plot for the beginning versus the ending centrality gaps. So a positive centrality gap means that the majority members are on average more central to the network, which means their work is more likely to be engaged with. The negative centrality gap then corresponds to the situation where the minority groups work. So the most important feature of this graph for the argument that I'm trying to make is that the slope of the regression is greater than 1. This means if you start with a positive number, you expect it to increase by the end. For example, 0.5 would increase to 0.6 with a slope here of approximately, meaning the initially favored majority group becomes more favored after this process. That is, starting with an advantage can create a feedback loop where you become more advantaged as time goes on. So I'm going to skip the specific results for running out of time, already be out of time. I'm going to skip the specific results for the majority versus minority groups, but hopefully it's intuitive based on the previous models that I showed that the minority group is more likely to be disadvantaged at the start, and so more likely to suffer from this sort of runaway method. Okay, so I'll return to this slide briefly at the end here just to say that this model is obviously oversimplified. But what I hope is that it serves to show the plausibility of something like a Rowley-Matthew effect for citation gaps, and that there's reason to take these sort of feedback loops more seriously and to consider them when we develop our pictures of well-functioning science. This is, of course, not to say that all models of academic communities must include considerations of social identities. Modelers often have to simplify, and we can learn a lot from models that ignore aspects of social identity. My point is just that we ought to be careful in forming opinions on, arguing for, or enacting policies and reforms without first doing due diligence in investigating how they impact already marginalized groups.
Thank you very much. That was super interesting. So yeah, and maybe you can, if you want to have the camera more, no, it's actually fine. Stop sharing the slides. Right, do we have any maybe clarification questions at first? Anything? Yes?
Okay, two clarification questions. One, for the first model, I was a bit surprised by the weakness of the effects you showed. So I was wondering how you came to the homophily parameters. Because, I mean, in the most extreme homophily, you would expect much stronger effects if groups are actually not connected. Just wondering kind of what strong homophily was in your model.
Okay, so the homophily, for the most severe homophily, the in-group linking probability was 0.09 and the out-group linking probability was 0.01. So you were 9 times more likely to link with an in-group member. I'm not sure what you mean by the weakness of the effect, because the citation gap being 0.34 means a majority group member is cited twice as often as a minority group member, which to me seems like that's kind of a big difference.
I agree.
Yeah.
But then these probabilities also actually seem truly extreme, and I'm surprised just because I don't quite
So one thing to say is that compared to, if you're looking at empirical results on citation gaps, there's a lot more factors involved there. So if we combine the network structure and bias and the productivity gap and the dropout gap, et cetera, all those things kind of add up to the overall citation gaps that are empirically observed. Is that answering the question?
Yeah,
so I don't think it's really that weak. Even like the cases where you might think more reasonable values of homophily, there's still like fairly large citation gaps in the models. I mean, I guess like 0.1 looks like a very small number, but if you interpret that in terms of citation chances, it's
sure. No, it was more of a modeling question to understand, because intuitively I would have expected that the gap is much closer to probability. Because at the extreme, I mean, it must be, right? If you're not connected to any outgroup member, you only cite the in-group that converges. But okay, in the second clarification, it's more about your argument in the last model, because that effect seems to appear, irregardless of when peer review happens, and you still at least learn about some papers because they're amplified in this kind of directed network. So how exactly does the abolition of pre-publication peer review change this effect?
Yeah, so the argument there is that, so the model basically demonstrates a mechanism by which this runaway Matthew effect can occur. And then I argue that it's likely to be worse if we abolish pre-publication peer review because of the specific features of our current system versus post-publication peer review. And in particular, in our current system, we have at least one powerful mechanism that cuts against the runaway Matthew effect, which is publishing in a high-quality journal. And that mechanism is maybe not completely detached from social identity, but is much more detached from things like social identity and centrality in a network and things. So the argument isn't that we're never going to get a runaway Matthew effect in our current system. The argument is that it's likely to be worse if we abolish pre-publication.
Okay, any more clarification questions?
Just a very short one. Thank you. So for the network constructs, the question is, the degree of each node ensure to be the same in both groups, or does that vary as well?
Yeah, so if you have a minority group, then if you have just in-group linking probabilities 0.09, out-group linking probabilities 0.01, minority group members have fewer people that have higher linking probabilities, and they're going to have fewer connections overall.
But then to what extent are driven by the differences in degree rather than the activity?
Yeah, so I didn't actually really distinguish those two. So the idea is that if we have homophily in this network, you'll get these differences in citation patterns. Now, homophily affects who you're connected to, but it also affects the degree, especially when there's a minority. Is that?
Yes, the question is then, is it more due to simply the number of connections or really the homophily? So the way the network is constructed is that it influences both at the same time.
Mm-hmm.
And so varying this parameter of homophily is not only changing the connectivity, it's also changing the actual, let's say, number of collaborators.
Yeah.
So then it's a different effect, and so that is not necessarily effect immediately of the homophily, but rather of the amount of content.
I guess what I'm saying is that the homophily, the way I've included homophily, just affects both of those things. So it is due to homophily.
Yeah.
But you're right that there's these two different things, and I haven't distinguished them in the models. Yeah, so I mean, one thing that lends to the interpretation that it's not just connectivity, that it is like the sort of clustering, is those citation ratio gaps, where the minority group members cite other minority group members at a higher rate, majority group members cite majority group members at a higher rate. And so that shows that at least part of what's going on is the clustering, even though there's still probably likely some effect from the.
Okay, yes.
Really interesting. I was really struck by the model, and I think it's really nice to conceptualize something as abstract as citation gaps. Just adding another dimension to this bias, and actually I would be just curious to think how you think this rationale would really fit in, or maybe add another dimension, is often one of the reasons that is stated for not citing the work of minority scholars is often that they focus on minority issues. So take in the US or just anywhere around, like you focus on, say, issues of diversity, or issues that may focus on, say, one segment of the population that may not relate to majority scholars. So often that gets sort of added as another layer, or of majority scholars don't typically cite the work of minority scholars because it then tangentially does not relate to their scholarship. So I just, would be curious to hear about how that would fit or extend, or
Yeah. So that's certainly something that is relevant to these sorts of effects. So in terms of including that in these particular models, it might be a little bit difficult, because you'd have to first say, okay, we have these networks, and then now people are working on different topics, and now I have to like code each paper according to which topic it is, and things like that. But I do think it's fairly intuitive to see how certain social identity groups are clustering, maybe even in a subdiscipline that's focused on these issues within a larger discipline. It's going to affect the citation chances, especially when there's some probability that people from the other subdisciplines are just going to not look at the work that's coming out of that subdiscipline.
and it's another sort of challenge to this citation gap.
Yeah, so some of the citation gap studies focus on entire fields. Some of them focus on subdisciplines. So for instance, there's one study that I put up in sociology that it said we didn't find any citation gaps, but they looked particularly at the Journal of Social Problems, which is something where it's dominated by female scholars. People publishing in that journal are going to be looking at that sort of work, which is maybe not valued the same way by people who are publishing in other subdisciplines of sociology. So certainly the view of the work seems to be coming into play in that study.
Thanks a lot for the talk, really cool model. I was wondering, like, if it would be possible that would like test your model based on real life data, like the homophily indices and like the minority majority ratios from like a given subdiscipline, and based on that kind of try to predict the impact factor, for example, of some of the scholars in that. What would be your take?
Yeah, I mean, so one thing to say is that because there's all these other factors that aren't included that I know are important, quantitative predictions are going to be very complicated and probably not possible. But thinking about whether the homophily within a discipline correlates at least with the size of the citation gap, certainly that's possible. I started to sort of think about that. I hired an undergrad to make a spreadsheet of all these studies, show here's the representation of the field, here's the gap, is there any information about homophily? And the issue that I ran into is that there are, I think he found 8 different measures of citation gap. So there's this thing called the citation gap where, women and minority scholars are less likely to be cited, but how exactly that is measured is different across each study. So then I'd have to normalize that somehow, figure out how are they measuring homophily, normalize that somehow. And so it seems like a much longer term project that I need to work with someone who knows more about these sort of large scale studies than I. But yes, certainly there are some like qualitative predictions that could be tested based on.
I see, because one of the cool things would be that you would make like a modular model with like different factors of like biases and everything, and you would gradually add them to see like how much each of these factors play a role in one subdiscipline, so that you can really like break down why this this gap is happening to begin with.
Yeah, so one thing, so when I put up the slide that had all the little like the different factors that may or may not be relevant, I kind of put it on a slide where there's little nodes and connections. This is because in my mind I'm sort of thinking of a kind of like Bayesian network, basically, where like these factors like all sort of like combine, not additively necessarily, but combine in a certain way. Testing a model like that, much more difficult, because you then have to have information about all of those things for all of the different, you know, disciplines, subdisciplines, countries, etc. So yeah, but in the ideal world.
Daniel?
Yeah, maybe building on this. So you mentioned in the first slides that there are some fields where the gap is reversed. So are these also fields where the minority and majority are reversed?
They are not. So
Because
construction studies.
yeah, exactly.
And,
I remember that. I don't want to be too stereotypical, but I thought maybe that's not reversed there. I don't know.
No, there's certain areas within construction studies where it's reversed. I'm not that versed in construction studies, so I don't remember the exact name of the subdisciplines. So those studies are interesting, and they come up with some reasons for why there might be this reversal. So they're both male dominated, and if you look at the number of articles that cite women are cited less often, but if you look at women individually, they are cited at a higher rate. The one thing they propose is that because there's like all these male stereotypes, they're male dominated, women who aren't getting, you know, the support they need drop out of the field, and who's left are the sort of superstars. And so when you look at these, how many citations are accumulating to those individual authors, they're getting more because they're the superstars that are left after this like pretty severe, I want to say filtering process, but I think I'm just Aiden's talking.
Survivorship, is that survivorship bias?
Survivorship bias, yeah. At least that's what they sort of threw out as like one possible explanation.
Thank you for your talk. I would like to drive your attention to things. First thing is that in your first model, you had fixed assumption that connectivity is driven mostly by centrality to ness, which according to network information diffusion studies, because the fact you deal with information diffusion here is not, it's not sufficient centrality measure, and because, for example, also distribution of this measurement matters. So that's one thing, and also the assumption, your assumption can be adjusted with this, like, I don't know, gossips, spread of information.
Yeah. So in the first set of models, I didn't provide any centrality.
Connectivity is a centrality measure. One of centrality measure. The number of hops between any two nodes in a network is one of centrality measures.
True. But I didn't actually provide that for the first set of models.
Only degree?
So for the last model that I provided, I gave a centrality measure.
So what was the structure?
So in the first set of models, I was pretty much just talking about the effective homophily, so the in-group linking probability versus the out-group linking probability. As was kind of pointed out, as sort of like vaguely gestured at, you know, connectivity and clustering and stuff like that. For the the last model that I provided, I did use a centrality measure, which was just based on the weight of incoming nodes, which, as you mentioned, isn't totally sufficient. So I did also check that with a measure of like betweenness centralities. So that's based on shortest path lengths, but of course there's weights, and so lower weights are like further away, longer paths to traverse. So I did use a few different centrality measures for that, which will make it. But does that help?
Yeah, and the other thing is that there is not in citation bias, but in co-authorship networks and collaboration networks in science, interaction between gender network composition and structure has been shown. So also individuals, when they are dealing with the network structure in a field, they would act differently depending on gender composition, but also on the structure. So if you have, for example, a male-dominated field, women would tend to build ties with central men because it advantages them in further collaboration. So maybe it also has maybe it also plays some role in citation bias. And the last thing is that there's a very interesting work of Danielle Bassett that deals with gender bias and ethnicity bias, and these are very recent works from this year and last year. So also in US context. So
well, maybe I will ask you for those references during the coffee break. Thank you.
Thanks, Hannah. That's a really interesting talk. And as one of the previous commenters said, I really like that, at least in principle, we could apply some empirical data to test or evaluate the model in some way. And I think it's also interesting, like the problems that you encountered with this undergrad you hired struck me as very.
Not with them.
But the problems that you and the undergrad as collaborators encountered are similar to problems that scientists in other domains encounter when they're trying to evaluate models. So in climate science, when they're trying to bring in parameters from experimentalists into their models, they encounter the exact sort of same difficulties. So I think that's really interesting. Sort of going to like back to some of the issues around replication crisis and some of the data that inspired this model about citation gaps, I kind of wonder, like, if we go back and look at those studies and we look at like maybe some of the things like the construction studies, like if in some way like those would replicate, are the effects they're identifying, would they continue through time in the same subfield? Do we see changes? Like how much do we trust that base data, especially when we get down to like the subfield level?
Right, so a couple things. So the two studies that I referenced that I said are across disciplines and different countries, those are sort of meta-analysis studies. So hopefully that increases your confidence a bit that the effect is real. In terms of the particular subdisciplines, the idea of replication, I'm not an expert on it, so if someone wants to correct my thinking about this, the idea of replication is slightly complicated because a lot of these studies like focus on particular journals, like the one I mentioned in sociology. They focus on particular timeframes. There might be different institutional contexts across different timeframes. And they use different measures, which like really annoys me. So there was one response to the Dion et al. Article said, oh, if you control for this and this, then the citation gaps disappear. But they didn't just control for that and that. They changed the measure of citation gap. And they changed it to something that isn't as good of a measure. So the Dion et al. Article is talking about specifically articles where women are lead authors. And they changed to articles where there's any woman co-author, which is not as good because there's well-known effects where if you have diverse teams of authors, you get more citations, and that totally like changes what you're measuring. So that might have been just a tangential rant, but like talking about replication, it doesn't seem like, unless you have a standard measure, you might just get a new study that uses a different measure and they call it a replication of it. That's what there was a connection. Does that answer the question?
Yeah, no, I mean, I sort of I get the difficulty, although in some sense, like, if you're not being sort of incompetent, which it sounds like maybe that sex site reference like to some degree is, but actually having like different approaches and different measures to do sort of conceptual replications is maybe a virtue, because you're not like too narrowly trying to replicate the results, but actually coming at the same idea from different angles.
I mean, but so the different measures get at different things. So that's one difference, right? Like women as lead authors versus any woman author. I feel like one of those is a much better measure than the other. There's also measures of looking at papers published within a journal versus measures that look at individual researchers and their citation counts. And so those, I feel like there's trade-offs there. I mean, there's different sort of factors that are relevant. So the survivorship bias is relevant for looking at individual researchers, not as much for looking at papers. So those I can see they're getting at sort of different things, but then would you want to say, well, we have one study using the papers and one study using the authors. Are they really a replication if they're measuring same general phenomenon, but like getting at different aspects of it? I don't know. I'm not an expert on replication.
I just wanted to make a short comment because that might be perhaps more general. So the question of replication. So let's say replication of studies, especially experimental studies, makes a lot of sense, right? You're gathering new data again. But in a sense, this is more like history, right? So there is a certain publication record. There were a certain number of publications. There were these authors involved there. They published this, not something else. So for a lot of, let's say, studies that have this particular type of replication is a sort of difficult question, which you actually already answered in the sense that there are different results in different contexts, in different times, and different disciplines. And so there's not one single answer, perhaps even to the question, is there yes or no citation gap, because it changes continuously. So the concept of replication in this, let's say, well, depending on what you're interested in, it has a more historical, for these more historical perspectives is perhaps something that is also challenging to define in itself, because what are you actually trying to replicate? It's more a problem, I think, of integrating all the different types of results that there are about all of these different things, and the difficulty of all the different measures and selection biases and whatnot, than really question of replicability.
Yeah, I mean, maybe it's definitely different than like experimental replicability. I think it's getting at like some of the similar issues, like is this a statistical artifact? You know, if somehow we were to like rerun history many times, would we see this same effect arising from the same general population structure, so on and so forth? Thinking about how would we get at that?
No, exactly. So then it makes a lot of sense, but then it's more a problem of inference instead of a problem of replicability, because so we can't replicate it. We only have this one data set that is exactly what it is, and there's not much that we can change about it. There's some difficulties of gathering the data, of course, and it might be proof data gathering, but then it's a problem of inference and a problem of modeling it, and a problem of inferring the correct results from that particular single data set that we have and gather new data.
Yeah.
All right, maybe we can continue this in the coffee break just now. Let's thank Hannah again.